Hello, we are Team 7347, and this is our video presentation of our project's progress at the end of Sprint 1. Our team is designing a software reverse engineering framework designed to streamline and unify the malware analysis process onto one platform. Our goal for this sprint was to allow a user to disassemble a binary to view pseudo-C. In order to accomplish this goal, we split the goal into 3 distinct tasks that converged to finish our sprint's user story, as well as building the bedrock for our future sprints. This demonstration will be outlined by these tasks. One of our tasks for this sprint was to overcome obstacles that presented themselves in continuous integration. The first of these obstacles was the fact that we are developing and testing plugins for a paid third-party software, Binary Ninja, a reverse engineering platform. Obviously, we can't host a Binary Ninja executables and license file, so we had to explore the open source integration service, Travis CI's privacy options to encrypt these sensitive files with our running instance's public key. The second difficulty we faced standing up CI services had to do with shortcomings of our Binary Ninja license. Because we are developing for the non-commercial version, we cannot access the Binary Ninja's API except through GUI-triggered plugins or Binary Ninja's Python interpreter. This presents a challenge running tests during CI because Travis CI only supports headless runs. We figured out that we could run Binary Ninja with a virtual display, and after exploring lots of very heavy GUI automation approaches, realized that Binary Ninja runs the init method for each of its plugins voluntarily on load before the plugin is triggered. So we decided to expose testable information by checking for a Travis CI environment variable in the init method and running external diff tests on the information exposed. This sprint, we put all these pieces together to have a working build status on our master GitHub branch. Our second task for the sprint was adding UI elements to the existing default interface of Binary Ninja. Binary Ninja utilized the PyQt5 application framework for graphical user interfaces. In order to implement any changes to the Binary Ninja's GUI, we had to research what other GUI plugins had been made for the application and how they were implemented. We also had to learn how the PyQt5 framework was being used in the context of this application. Our first task was to implement some visualization which could be used to display how likely it would be to reach some branch of code on individual runs. It would be ideal to use some visualization libraries such as Matplotlib. However, we found that there were compatibility issues between such libraries and PyQt5. As a result, we used PyQt5's built-in drawing methods to draw a pie chart shown on screen, which can signify the likelihood of traversing a specific branch. The pie chart we created is not yet integrated into Binary Ninja application and is only conveying simulated data. In Sprint 2, we will be able to integrate with the pie chart with actual data into Binary Ninja by using the Binja UI API. Our final task was to update Binary Ninja for use with RedTech, an open-source machine code decompiler. In order to easily manage dependencies, guarantee the same setup process across machines, and enhance security, as it will be potentially handling malware, we built our own copy of RedTech in a Docker virtualized container. We've written a simple Python API that was copied into the container and listens for HTTP POST requests at localhost 5000. When we create a POST request directed at the appropriate port with our malware's executable files, our container will run RedTech's decompiler on those files and return the decompiled versions. This concludes our video demonstration for Sprint 1. Thank you.